exam. You wasted a whole year of your life for nothing. Okay? So, 2013. Tell me the givens, Lewis. Read it to me.
Okay. 4.32 grams.
4.32 grams of. Okay. And we have a reaction for this. SO2 Cl2 gas equilibrates to SO2 plus chlorine. And then what else is a given on there, Lewis?
1.5 liters.
Okay, so we're given 1.5 liters, and is that like the volume of the flask or something?
Yeah.
Okay, so that's like V. V is liters. Okay, tell me more givens.
400 Kelvin.
400 Kelvin. And that would be probably our temperature. And I want you to write down these givens, okay? Because you shouldn't have to reread problems 5 times to get it. You're going to pull out your givens. Keep going. What's another given? Oh, there's one more. It's endothermic. Literally every term is going to be important to us, okay? So I know I can read endothermic, but I want you to write down delta H is what? Is it positive or negative? Positive. So think now before we move on. If it's delta H is positive, where is that in our reaction? Where is energy? Where is heat? In the reactant. So we all clear endothermic. Energy is a reactant. That is important because you will forget that it's endothermic about halfway through this problem. Okay, I think that's all of them. What's the question part A? Okay, so with that decomposition, what's the pressure? Kevin, what do you want to do first? Okay, why are we getting this to moles? Okay, so we're seeing that the SO2 Cl2 is decomposing, and you are seeing that's asking for pressure. So the question being pressure means I've got V, I've got T, I'm looking for P. You only have grams to start with. You really can't do anything else. You don't have an equilibrium expression. You don't have a K value. You can't do that yet. So you have to just use your generic gas laws by converting this to moles. So 1 mole of this, I can help you guys on the molar mass here, is 134.96 grams. So that gives me 0.0320 moles. Oh, note to self. Only one question on this entire FRQ part of the exam is scored for sig figs. But you don't know which one it is. So what should you do? Use correct sig figs at all times. So, and they don't decide until the reading, until June, as to which question it is and how many are accurate. So for what I would say is 100% make it exact sig figs you should. Quick review, multiplication and division. When you're adding and when you're multiplying and dividing, like here, you count sig figs. How many sig figs should be in this problem? 3, because this has 3 sig figs, so that's why I've recorded this to 3 sig figs. That front 0 is a placeholder. It's not significant. The back one is significant because it's saying it's exact. And this is our N value, by the way, for this guy. But sometimes they'll say, man, this is a data question where it's a student laboratory question, and I want sig figs in the correct range of plus or minus 1 sig fig. But they don't decide that till the exam, so try to always make it exact. And if you're not sure, go with 3. Okay. So there's our N. So then what Kevin said was to do what? PV equals nRT. So go ahead and set up your PV equals nRT. What variable are we solving for? P. So I like to go ahead and just divide by P to show my generic setup. Oh, and on I'm telling you all my tips from the webinar. I'm sorry, we're solving for pressure. Sorry, solve for V. Solve for P by dividing by V. On the webinar I was at the other day, they said if you do not show your mathematical setups for things, and even if your answer is right, they will not give you credit. Okay? You absolutely have to show even minor things like converting to Kelvin or converting your atmospheres or something. So this is already, I think, in Kelvin. So our P is equal to nRT over V, N being 0.0320 moles, R being 0.0821 atmosphere liters per mole K. T being 400 Kelvin over V of 1.50. Was it 1.50? Yeah. Okay, liters. Sorry, I wrote 1.5 because that's what Lewis told me, but this is my pressure. So I got originally 0.7007 atmospheres, but we would need to do what? 0.701 because we need to get 3 sig figs in our problem. And they said to label Sometimes an answer is similar to like between A and B. They said make sure you're labeling very well. So like I would say, at the top of this is A, and then maybe even just put like a little line dividing A and B because they don't want to, they can't give you points for A that you wrote in B. So even if you wrote the answer to A and B, they can't give it to you. It's just their standards. Okay, part B, what's the question? Give me the whole spiel. Shannon, read it to me.
When the system operates program 100 the total pressure in the container is 1.26 atmospheres.
Okay. Calculate the partial pressures of CL2 and the other one? Okay.
Does it matter if I write it zero?
No, go for it. Yeah, you can write it that way or just 0.7. Okay.
I was joking.
No, that's all good. Okay, so as Shannon was saying, she said pressure total was 1.26. So write PT is 1.26. And it's at equilibrium. So now we actually do need to start writing a icebox. So, dang it, I already read that reaction. Way at top. Equilibrates to SO2 and Cl2. Okay. So what do we have here in the I? How did you get that, Jack? You got it. Okay. So don't forget part A gives you answers for part B. So please don't be scared to go, oh, I just calculated this. Whatever you got there, plug in here. Before the reaction begins, you have 0 of both of those. What do you have in change? We neither. X. Okay, so mine's X plus X plus X. And if these were coefficients of 2, what would you have on the right side? If those were coefficients of 2's, you would have 2 X's there. Don't forget coefficients matter here. Yes, ma'am? No, it's assumed that's what you're doing. And if you put a random number there and it wasn't what you had in A, let's say you put 1 atmosphere there, you would not get the point for one of these parts on part B. You would get like your answer, but you wouldn't get the initial because you just didn't realize you already had the pressure. Okay, so this is 0.701 minus X, X, and X. So remember when you do KP expressions, because this is pressure, right? Does it say, oh yeah, do we need to do a KP expression? No, we don't. We don't need to right now. What do you guys want to do to find the partial pressures? Set me up first. Give me what I know.
Concentration of the X times X over 0.7.
But that's going to give me, that's going to help me find the equilibrium value, right? It's not asking for the equilibrium value. I just did this with mixed group, number 60, multiple choice. What the question is, what are those partial pressures? Knowing the total pressure is 1.26. Products of reactants.
No, said all those added together equal to the total pressure.
Got me? This is not an equilibrium, truly KP expression right now. This is just like, hey, all this crap added together is equal to total pressure. That plus that is equal to P total. Everybody always mixes up KP and P total. So P total was 1.26 atmospheres, and they want you to tell me what each of these are. So be active with me. Try to calculate. Tell me how you would, maybe tell me how you would simplify this right now. Tell me more. That's an addition, sorry. How can you simplify this? Yes, see that's a minus X, and that's a plus X, and that's a plus X. One of these X's will cancel with itself, so 0.701 plus X gives you 1.26 atmospheres, because one of these cancels with each other. Okay, so then what's X? So what's the answer? Okay,
So you have
so
to show subtracting.
no, you can write this and then
write.
this. Yep. 0.5559. What? What? Is that right? That's right. Okay. All right. So before I move on, sig figs are an addition and subtraction. We just did sig figs for multiplication division. You count sig figs and you record sig figs. The lowest one, right? This is addition and subtraction. So what you need to do is when you're subtracting, you count decimals. Okay, so it's not the sig figs, it's the decimals. So you're taking 0.26 being the 2 decimals, subtracting 0.701. So two decimals would be your limiting. So this needs to be recorded to what? To two decimals. So what would that need to be? Point. Yes, because whenever you have an addition and subtraction, sig fig rules slightly change. Addition and subtraction count decimals, not actually true sig figs. So you do 1.26 minus 0.701. This one right here, having the two decimal places, limits our final answer to 2 decimal places, which is this, but rounded to 2 decimal places, 0.56 atmospheres. And who is this describing?
That's X.
But who is that?
That's
So what you're going to do is you're going to write P of Cl2, so the chlorine's partial pressure equals, just so you have less to write, okay, the partial pressure of SO2, and so they equal this, okay? So what is the partial pressure of SO2 Cl2 equal? At equilibrium, remember. At equilibrium, what was SO2 Cl2?
that's what you said, 0.701
Minus X, right? So you take what you had here at the equilibrium for P of SO2 Cl2, dang it, 0.701 minus 0.56. 0.14, thank you, 0.14 atmospheres. Let me finish setting this up real fast. Okay, so that's the P of Cl2. So I don't have my points on here. I'll have to look at the point values for sure, but you probably got a point for your setup of your icebox, a point for these two equaling each other at the 0.56, and a point for your final here as well. So 3 points on part B. On part C, what do you need to do? What's the question? Write the equilibrium expression. Write it. Tell me how you would write it. On Kp is equal to. Thank you. No one's putting concentration, right? This is not a concentration question. They will not give you credit if you put concentration, even if the whole setup is right, people. It's just not conceptually correct. So you'll do your two products, multiply by each other, coefficients of 1 become exponents of 1, and P of SO2, Cl2, partial pressure on the bottom. Do not even put brackets. If you put brackets, I mean, you're talking about the concentration for pressure, which doesn't make any sense either, and they will not give you credit. Okay? So sometimes the FRQ points are very specific, so you just want to make sure that you're trying to cross your T's and dot your I's, and then you plug in your two concentrations here, 0.56 atmospheres squared over 0.14 atmospheres, and that's Kp is equal to 2.2, no unit. So if Kp is equal to 2.2, what does that tell you about the favorability of this reaction? Yeah, they're favored because it's greater than 1. All right, so I'll finish up. Actually, you guys finish 2013, the one we're working on right now, 2010, which is number 2, and 2011, which is it's 2011B. Is that the third one? Yes. Okay. So I want you guys to go through 3, and then I will help out, and I'll do number 2009 on Monday, and we'll do 2010. We're going to finish equilibrium Monday. We'll keep practicing it, but it's not going to be our main focus after Monday. Okay, thanks, guys. Announcements. Somebody told Clayton what we did today. He doesn't have much to review, but. So you've got 2.5 FRQs to do and knowledge bullets. And please share your knowledge bullets with me. And if you have not started, it's a little long. But do pay attention, like some of that information will give you quick reminders of things you have forgotten.